Hey there, gang. In this video, we're going to take a look at scientific notation. Scientific notation is a compact way, compact means a shorter way, of writing very large or very small numbers. And so the format for scientific notation looks like this. It's going to be in the form of a number, we'll call that A, times 10 to some power. We'll just say the nth power for now. So we'll use a couple of variables there and then fill in regular numbers when we do some examples. But the key here is this number in front, okay, what I'm calling A, has to be between 1 and 10. It can be as small as 1, but no more than 10. Okay, so it has to be a single-digit number is the key for scientific notation. So we're going to practice several problems here where we're going to take either a really large or really small number and convert it to scientific notation. And the nice thing is, all you have to do is move the decimal point and be able to count. So to go from what we call standard form, that would be the regular form for a number, to scientific notation, you have to follow these two steps. The first step is to move the decimal so that the new number is between 1 and 10. Again, it has to be a single-digit number. That's step 1. Step 2 is to write the answer in scientific notation using a power of 10. And so the way we do that is if we moved the decimal to the left, then the exponent is going to be positive. If we move the decimal to the right, then the exponent is going to be negative. The easy way to remember this is if we start with a really large number, then you'll have a positive exponent in scientific notation. If you start with a really small number, you'll have a negative exponent in scientific notation. Okay, so let's look at these examples now in this chart. Number 1, we have the standard form number of 937,000. So the first thing I want you to think about is this a really large or really small number? Well, 937,000 is a really large number, so you know your exponent in scientific notation is going to be positive. Okay, so the way this is going to look is I'm going to have some number, I'm just going to put a box here for now, times 10 to some power, and your job is just to fill in those two boxes. Well, the first box we get by imagining where the decimal point is in 937,000. It would be there to the right of that last zero. And so to make this number between 1 and 10, I need to move it to the left. It's going to go 1, 2, 3, 4, 5 spaces. I have to go 5 spaces because if I go 6, I'm going to get a number that's less than 10. 0.937 would be too small. If I go 4 spaces, I'll get 93.7, and that's too large. So again, you're shooting for a number between 1 and 10. That would be 9.37. So that's what goes in this box. And then how many spaces did you move your decimal point? Well, again, we said we moved it 5 spaces. So this is going to be 9.37 times 10 to the 5th power. You know from your exponents video that 10 to the 5th power is 10 times itself 5 times. So if you multiply 10 by itself 5 times on a calculator and then took that times 9.37, you would get the answer, 937,000. All right, the next one. We have 76,820. Again, you know this is a large number, so your exponent is going to be positive. So your decimal point is here. We need to move this decimal point to the left, and let's count the number of spaces. 1, 2, 3, 4 spaces for this one. That's going to give us 7.682. And since we moved it 4 spaces, that's to the 4th power. Okay, number 3. This time we have a smaller number. So when you have a really small number, 0.00982, you're going to have to use a negative exponent in scientific notation. And the reason being is we're going to be moving this decimal point to the right. Okay, so I'm going to find my decimal point. I'm going to move it to the right 1, 2, 3 spaces to get 9.82. But because I moved it to the right 3 spaces, then I'm going to have a negative 3 as my exponent. So it's 9.82 times 10 to the negative third. The same thing is going to happen for number 4. We have a really small number, so I'm going to have to use a negative exponent in my scientific notation. So here's my decimal point. I'm moving 1, 2, 3, 4, 5, 6 spaces. So this is 1.4. And my exponent is going to be a negative 6. All right, last one here, number 5, 4,671. Think about whether your exponent will be negative or positive. Our decimal point is to the right of 1 here. This is a large number, so our exponent is going to be positive. I need to move this 1, 2, 3 spaces to the left. So this is going to be 4.671. 4.671 times 10 to the positive third power. All right, for the next few examples, we're going to just look at the scientific notation form and decide whether or not it's correctly written in scientific notation. And if it's not written correctly, we'll change it. So look at number 6. Remember, the rules for scientific notation is you have to have the problem written as times a power of 10, which we do. We're taking this times 10 to the 7th. And this first number has to be between 1 and 10. So what you're really looking at is 2.98 between 1 and 10? The answer is yes. So this is correctly written in scientific notation. Number 7, we are multiplying by a power of 10, but take a look at the number in front. It's 11.4. Okay, you cannot have a number that is greater than 10 in that first position. So what we need to do is we need to alter that number so that it is between 1 and 10. The way I'm going to do that is I'm going to take the decimal point and I'm going to move it 1 space to the left. So when you do that, you get 1.14. However, when you move a decimal point in scientific notation, that is going to change the exponent. And so what you have to do now is you have to think about how that exponent is going to change. Well, if you remember in the examples above, every time we moved left, our exponent was positive. And so every time we move 1 position to the left, we're increasing our exponent by 1. We're adding 1. There's an easy way to remember this that might help you for this section. The acronym LARS, and that stands for left, add, right, subtract. Okay, so in this problem, since we're moving to the left 1 space, I'm going to add 1 to that exponent. And so now this is 1.14 times 10 to the 4th power. All right, let's look at number 8. I have the same issue in number 8. Take a look at your number here. It is too large. Okay, so I need to move that decimal point 1 space to the left to make this 8.51. Because I moved to the left, I need to add 1 to my exponent. And so negative 5 plus 1 is going to be negative 4. So this is now times 10 to the negative 4th power. All right, number 9, we have 6.7 times 10 to the negative 2nd. This one is correctly written in scientific notation. 6.7 is between 1 and 10, so I'm going to say yes for this one. All right, let's go to the back side now, and now we're going to do the opposite. This time, I've given you the scientific notation, and you're going to convert to standard form. You have to think the opposite on this, okay? When you're given the scientific notation, you just have to think, do I have a really large or really small number based on the exponent? Is it positive or negative? And that tells you what direction to move the decimal point. So number 10, we're multiplying 2.085 times 10 to the 5th power. Since that's a positive exponent, you know this is going to be a large number, so you're going to take that decimal point and move it to the right. So the way I like to do this is I like to write out that first number, 2.085. And since I'm going to the right, I'm just going to add a lot of zeros here to the right, and then I'll erase some as I need to. But now I can move this decimal point the right number of spaces. So I'm moving at 5 units to the right. So that's 1, 2, 3, 4, 5. So that's going to end right there. And so that means that I don't need these zeros here anymore. I have the number 208,500 is what this becomes in standard form, 208,500. Okay, same thing for number 11, 5.388 times 10 to the 6th power. I have a positive exponent, so this is going to be a large number. So I'm going to write my first number, I'm going to put some zeros to the right, and I'm going to move that decimal point 6 units to the right. 1, 2, 3, 4, 5, 6. So the decimal ends there. So these zeros to the right of the decimal are not necessary to have. Okay, and so let's think about what this number is in standard form. This would be 5,388,000. Number 12, this time I'm multiplying by a power of 10 that has a negative exponent. So now I'm going to move my decimal point to the left because this is going to be a small number. Okay, so this time I'm going to put my number here, 5.25, and I'm going to put zeros to the left of that 5. It's going to look a little bit weird, but remember I'm going to erase some of those zeros. I'm moving the decimal point 5 units to the left. 1, 2, 3, 4, and 5. So the decimal goes there. So now this is going to be the number 0.00005525. So the number in blue is my answer, 0.0000525. Okay, a couple more here. 6.018 times 10 to the negative second. Again, a negative exponent means that you have a small number. So you're going to move that decimal point to the left 2 spaces. So there's 1 space, there's 2 spaces, and so this is going to be 0.06018. 1.62 times 10 to the negative 7th. Again, you're going to get a small number here, so you're moving your decimal point to the left. So put in your zeros. It's going to go 7 spaces, so 1, 2, 3, 4, 5, 6, and 7. So my answer is going to be 0 and then point. There's 6 zeros to the right of that decimal point, and then we have 162. Always show me your final answer with 1 decimal point written, okay? Don't do your work and then leave it. Rewrite your final answer so I can see clearly where that decimal point is supposed to go. All right, and these last few examples, we're just going to compare these numbers. So on number 15, we have 2 numbers here that we're comparing, 7.42 times 10 to the 3rd and 3.128 times 10 to the 5th. We'll take a look at both of these numbers. Since they're both written correctly in scientific notation, both this number and this number are between 1 and 10, all you have to compare are the exponents on the powers of 10. The larger the exponent, the larger the number. Okay, 3.128 times 10 to the 5th power is going to be larger than 7.42 times 10 to the 3rd. So as long as you're correctly written in scientific notation, it's the exponents you're comparing, and since 5 is larger than 3, this will be a less than sign. The number on the right is bigger than the one on the left, so we use a less than sign. For number 16, again, take a look at your numbers here and here. Those are correctly written in scientific notation, so now we're going to compare our exponents. We have a -2 here and a -3 here. -2 is larger than -3, so this is going to be a greater than sign. All right, these last 2 examples we are going to take a look at the next time I see you in class. So this is where I'm going to stop the video, and until then, have a nice day. You're all wonderful people. Take care.